Hi, I'm Robert Hurt, and I'm an astronomer at Caltech IPAC. And today I'm here to take you on a guided tour of the basic functionality of version 4.0 of the FITS Liberator application. Now, the FITS Liberator is a very specific tool with a very specific purpose. It allows you to open astronomical image data in the FITS format and export it as a TIFF file, which can be opened in pretty much any image editing software of your choice, whether you're working on graphics for a publication or if you just want to do something cool for Instagram. Now, the reason we need something like the FITS Liberator is that the FITS format is very, very old. It was actually introduced in the 1970s, predating pretty much every graphics format you're likely to be familiar with, like JPEGs or PNGs or TIFF files. It was actually originally designed to be used with punch cards and was designed around 80 characters per line. But it was powerful enough that it is still used by astronomers today, as well as astrophotographers, as a way of storing high dynamic range calibrated image data. Now, if you want to make a pretty picture out of that, you don't really care about the calibration. You just need a way of translating that array of data into a grayscale image that you can then export and work with in other applications. I've been an advisor on the FITS Liberator project since its first version was introduced in 2004, and I've personally used it to produce literally hundreds of images that NASA has released covering astrophysics missions spanning infrared, visible, ultraviolet, and X-ray light. So I know it's a really powerful tool, and I hope it's something that might be useful for your own workflows. So let's dive in and just take a look at the basics of how the FITS Liberator works. This is the basic user interface for the FITS Liberator. And the good thing is it will look pretty much the same regardless of whether you're working on a Macintosh, a Windows PC, or under Linux. So let's go ahead and click the Open FITS file to start the process. I'm going to select a FITS file here of the Galaxy M51 from the Digital Sky Survey. And you see it immediately opens and it populates the image display panel with a view of that data set. We can sort of step around the interface and look at the different pieces here. In addition to the image display, we have some tools in a toolbar on the left panel. We have a histogram that displays the image statistics from the low data values to the high data values that shows up underneath the image. And this histogram can be particularly useful in helping us pick out where we want to chop off the data set at the black and the white points before we render it out as an image. Over on the right, we have our Open and Save buttons for opening the file and exporting it as a TIFF file. Underneath, we have a couple settings on the kind of TIFF we want to export. We can set the bit depth to either 16 or 32 bits per pixel. Either of them give us a lot of latitude in editing, but if you're working with a data set that has extremely high dynamic range and maybe you want to use some external HDR tools, you might want to set it to 32 bits per pixel to have a little more information. We can also set an alpha channel, which in this case doesn't matter, but some data sets have missing data, and we can either assign that missing data to be shown as black or as a transparency that we can then fill in with another image underneath. The options dialog is actually relatively simple. It gives us some color markers for interpreting lines on the histogram and an ability to clear our cache to sort of reset to factory conditions. We have a reset parameters button here that if we actually open the image and twiddle with the way that we're displaying it, clicking this will restore it to the way it looked when we first opened it. We have a flip image checkbox that lets us reverse the way the image is displayed vertically. This is related to the fact that FITS data typically is rendered in a way opposite from most other image formats and typically has to be enabled, but you can disable it if you want. There's also a freeze settings checkbox that is helpful when you're working with a data set that might be one of a series of images that have all been collected in the same way and have the same calibration, and you want to apply the image settings you've figured out for one image equally to all of the other data sets. By selecting freeze settings, each time you open a new image, it will use the exact same settings from the current image, and it will therefore output something that can be directly compared. Finally, at the bottom here, we have the ability to toggle the preview in the image on what happens to pixels that are being clipped off on the white end and the black end. By turning those off, we actually get a view of what the final image will look like as we export it.
but I personally like to leave these on because I always want to know what part of the data set I'm losing when I do that final export, because once I export it, I'll never be able to recover those pixels. So as you can see, I've actually been doing basic adjustments to the image by simply clicking and dragging on these little markers in the histogram tool. And that actually lets us define the most simple adjustment is what do we want the translation to be going from data values to the range of grayscales running from black to white. So in this case, I'll just open it up a bit so that we see the full range of the data. Click Save. And now I am exporting a TIFF file, and we're done. You can take that over into your image editor of choice and play with it from there. But let me take a moment to dig into a few more of the tools that we see here that may be helpful. For instance, we have the ability over here to zoom into the image or out of the image, which can be helpful if we're working with a particularly large image and we want to see what's going on in some detailed area. If we want to zoom it back out to show the full image, we can click the home icon up top. And if we have a large image that we want to expand to fill the entire screen, we can use this icon here to give us a full page toggle. This will go outside my capture area, so I won't bother demonstrating it here. Then the last two tools on the toolbar we have are alternate ways of setting the black point and white point from dragging in the histogram. And these basically sample values directly out of the image. So for instance, if I zoom into the image a little bit and I wanted to set the black point based on a region of the image, I could just click in there and that will actually choose the black point based on the data value of the pixel I clicked on. Likewise, I can do that for the white point. Say that I really was only interested in the faint things in the image. I could sort of click the point at which I want to clip the data, and then we bring it in. Or I might use that tool to click around till I actually find some of the brightest pixels in the image and let those define where I want the white point to be. So alternate ways of accomplishing the same task as dragging the histogram selectors down there. So that pretty much covers the basics of getting an image out into a format you can use in other applications. We will come back in the second video and talk more about the advanced scaling functions we have for dealing with images with particularly high dynamic range. But for now, I hope this has been helpful, and I hope that you might find some uses for the FITS Liberator if you like working with astronomical data.